Hello and welcome to my channel. In this smart video tutorial, I want to discuss the concept complex number. A lot of students have been making requests of this topic, so I have considered making a video on this complex number. So if you're new to this channel, consider hitting the subscribe button and turn on the notification bell so that by the time I upload new video, you get notified. Other than that, if you're a returning subscriber, please stay subscribed and keep watching this video and like this video, as we are going to talk more about the concept of complex number. So when you hear about complex number, what exactly do you think complex number is? Right, complex number is a combination of a real number and an imaginary number, and is denoted by C. That's a simple way I want you to understand. It's just a combination of a real number and you can say A should represent this real number and an imaginary number. So let's use B to represent imaginary number with an indication of this operator I, because A and B ordinarily they are real numbers, but when I is attached to this B, it makes the whole expression becomes an imaginary number, because I itself is what we call the imaginary unit, or otherwise called operator J, operator I. So that is just the basics of complex number. We say that it's represented with a symbol or letter C. So that is it. Sorry. And this complex number is always represented in this form. If you have A plus IB, this A is what we call the real number, or you can call it the real part. Then this whole expression is what we call the imaginary part. Right. So this I has a very important meaning at this point, and the meaning of it is the square root of minus 1. If you have this I to be square root of minus 1, it means other powers of I will have its own meaning owing to these basics we've established. Keep in mind that I said I stands for operator. It's an operator, so you can call it operator I. If you see it in this form J, it's still the same thing. It's an operator also. They both has this meaning. So some textbook uses I, some uses J, but they all the same meaning. So if I have I to be square root of minus 1, it means I square will be the square root of minus 1 all squared. If this square cancels this, say we have I squared to be just minus 1. Similarly, if I have I cube, I would not want you to go through the length of saying I times I times I, because if I have I to the power of 50, you will not want to go through this length or stress. So instead of you doing this, of course know that this method will still work, because you say I means square root of minus 1 and I times I is I squared. I squared is I squared. I squared itself is minus 1. So minus 1 times I will just give you minus I. So, but I want you to go by this length or this method. If you have I to the power of 4, you just split it to I to the power of 2 times I to the power of 2, because you know that according to this model, A times A times A to the power of M times A to the power of N. This is a model about what do we call it? Product law of indices. When the bases are the same, you take the common base and you add the power. So going by this model, if you add up this, if you take one of these common base, which is I, add up 2 plus 2 is to still give you 4. So this and this are essentially the same. So but then what is I squared? I squared has been defined here to be minus 1. So we are having minus 1 times minus 1, and this we evaluate to give just 1. So that's the same way you can also check for I to the power of 5, and for in this case I'll just say I to the power of 4 times just I, because according to indices there's an invisible 1 here that if you add up to this 4 to give you 5. So we know that I to the power of 4 already is 1. So 1 times I, we just give I. This is how you can be able to check for, even if you have I to the power of 9 I to the power of 15, I to the power of 29, I to the power of 54. You can go as much as you want to get the value for I. Alright, that is enough about I. So let's go further about the concept of this complex number. In the complex number, we have z to be equal to a plus ib. The number a, we have defined it as to be the real part of this z and is denoted by like this. When you see real part of z, we are talking about a. Similarly, the number b is called the imaginary part of z. In this case, we usually represent it like or as this. So this is talking about the imaginary part of b. So when you see them in textbook, you should be able to identify these notations. For example, if I have this like this, you should just know that this particular one is talking about the real part of this a. Remember that this particular one represents z according to this expression. And then if I have it in this form too, a plus ib equal to b, you should just know that it's talking about the imaginary part of this complex number. So but then when we want to ask what is z exactly, the symbol z can be used as a set of complex numbers, which is called the complex variable. So you can just call the z a complex variable. I hope you're catching the flow on complex number. So if you're enjoying the video already, please consider hitting the like button as you're watching along, and please, if you've not subscribed yet, hit the subscribe button because we need that to increase the algorithm of this video and also for us to build our YouTube channel. Thank you very much. So let's proceed. Two complex numbers are equal if and only if both real and imaginary parts are equal. For example, if I have a plus let's do this like this, and I have c plus bi. These two are equal if and only if a is equal to c, and in most cases, instead of writing bi equal to we use d here, sorry, instead of writing bi equal to di, we know of course that I can cancel each other, so we simply say b equal to d. Take note of that. So we only say when two complex numbers are equal, the law will only hold if and only if a is equal to c and b is equal to d. So that will help a lot. But another part I want to stress on is what we call the complex conjugate, or we just call conjugate of a complex number. If I have a plus bi, the conjugate of this a plus bi is simply a minus bi. So what exactly is this talking about? It means that complex conjugate numbers are identical except for the signs in the middle of the bracket. This and this are exactly the same. What changes is just the sign. Instead of having plus, we are changing it to minus. So when you have it in minus, you can as well change it to plus when we are talking about conjugate, complex conjugate. Alright, so I want to finally tell you about this particular one that is important. Since you know that z is equal to this, the representative of complex number, which is complex variable, so if you want to check in the complex variable of this z, we can say that the conjugate of a complex number, z is denoted by z bar. Alright, you know that complex number is represented or denoted by z when we have z equal to a plus ib. So the complex, if you want to check for the, when you see something like this talking about the complex conjugate of this complex number, it means you have a minus ib. I hope this is clear. So the next phase we want to talk about now is the addition, subtraction, division, and multiplication of complex number. So to add two complex numbers, we add each element separately. For example, if I have a plus bi plus c plus di, this expression can be evaluated to give a plus c. I'm adding up the real parts together, and then also going to add the complex part, which is b plus d. I notice that this I, they are common, so I just put it outside. So you can always add the both together. When I, like what I said, when we add two complex numbers, we add each element separately. So that settles for addition of complex number. Next we want to talk about is subtraction of complex number. In subtraction of complex number, to add two complex numbers, we are talking about subtraction. To subtract two complex numbers, we subtract each element separately. For example, if I have a plus bi minus, that's where the subtraction comes in, plus di. The result of this will be that I will subtract a minus c plus, then I'll also subtract b minus d. I'll put this I outside. So that settles for subtraction of complex number. We're going to solve problems to demonstrate this. Let's talk about multiplication of complex number. So here's a special case. To multiply complex numbers, each part of the first complex number gets multiplied by each part of the second complex number, in the sense that if I have a plus bi and this multiplies by c plus di, so what happens? I want to use this to multiply by this first part to multiply by this first part, and again this against the second, then second part against this first, and this second part against the second. Let's do that quickly. A multiplies by a will give us a multiplies by c, and then this will add up to a multiplies by di will give us a di. Again, bi multiplies by c will give us bci, and bi multiplies by di will give us bdi squared. So what's the next thing we need to do at this point? We observe that we're having I squared here, and we've discussed earlier what I squared stands for. If I is square root of minus 1, then I squared should be minus 1. So that means AC plus, this case we have that this one is common. So because it is common, we want to put it in the brackets, and we say here to be AD plus BC, place the I outside because they are common, plus what happens here? This will give us BD multiplies by minus 1. Keep in mind that I squared means minus 1. Alright, so of course if I have AC plus AD plus BC I, if minus affects this plus, it gives minus BD. That way we can be able to combine AC minus BD, and then that will add up to give us this other one, AD plus BC I. I hope this makes sense to you. So that's essentially how this can be combined together. So we want to do the last part, which is the division of complex number, before start solving problems. So when we talk about division of complex number, the conjugate is used to help division. The trick is to multiply both numerators and denominators, and by so doing we conjugate the denominator. We may not understand very well except I introduce some concepts. Let's say we have a plus bi, this is dividing c plus di. Let me put this in brackets. So what happened? The first thing you want to do is to make sure that after rewriting this expression a plus bi, you want to make sure that you use the conjugate of the denominator, which is this. And of course, if I talk about the conjugate of the denominator, I'm talking about c minus di. You divide by itself, c minus di, and use it to multiply by the complex number here. This is the operation you need to do. And of course, if you want to expand this, you just have the numerator multiplies by this, which goes the same way we did the multiplication. Denominator multiplies by this, and then factor out what's necessary. We want to see the main expression when we use real numbers to demonstrate this. So when dealing with complex number, the result of our calculation is also in general a complex number. That is to say, by the time we evaluate this, the result we will get will also have that shape of complex number, where we have our a plus ib. The result will always be like this, so keep in mind. So we're going to solve problems, and in further video we want to talk about the De Moivre's theorem, the polar to rectangular form, and as many as we need to consider. So let's watch out for these problems. So in these problems, we're going to solve them one after the other. The first one says 4 minus 3i plus this. So what we want to use is the commutative law of addition. In using the commutative, I think yes, should be O. Commutative law of addition. How do we use this? Look at, in this case, we have the real parts, and we also have the conjugate parts, or what we call the imaginary parts. So firstly, I want to bring out the real parts. In bringing out the real part, we have 4 minus 8, and then we still have the imaginary part minus 3i plus 2i. So here, when you add up this 4 minus 8, you have minus 4, and if you add up this, you have minus I. Keep in mind that I told you that your answer will always look like the complex number, the way we usually introduce it, as a plus ib. In this case, you can see your a, your real number, is minus 4, and the imaginary part is minus I. Right, let's consider the second number, the second problem there. In the second problem, we have 3 into minus 1 plus 4i minus 2 into 7 minus I. So we're also going to use the commutative law of addition for this. And how can we use that? We want to use this 3 to distribute into this, and also use minus 2 to distribute. And if you do that, you have 3 multiplies by minus 1, you have minus 3. 3 multiplies by 4, you have plus 12i. Minus 2 times 7, we have minus 14. And minus will affect to give plus, and then we have 2 times I to be 2i. Alright, so now we have to add up the real part, which is minus 3 minus 14, and then also the imaginary parts, minus 12 plus 12i plus 2i. And if this sum up together, you have minus 17, and then this other part will sum up to give plus 14i. And this is the result for that. The next one we're having is this. This is for multiplication, and that question reads, that's the III. It reads that 3 plus 2i multiplies 2 minus I. So let's work on that quickly. So what we need to do is to use the method I introduced when I was talking about multiplication of complex number. This first term will multiply by this, and this second term, this first term against the second term, this second term against the first, and this second term against the second term. That's the process we're going to use quickly, and then we'll get the result. So, and that is also commutative law of multiplication. Sorry, the other one was commutative law of subtraction, and this commutative law of multiplication. So I can do this in two ways. The first way is using 3 to multiply by 2, and 3 times 2, that will be 6. Again, 3 times minus I, that will be minus 3i. And 2i multiplied by 2 will give us 4i. Then 2i multiplies by minus I will give minus 2i squared. You can expand it like this, or you can as well break down this in this form. I can use this 3 to multiply by the whole of this, and use this 2i to multiply by the whole of this. Like, you can apparently split it like this, saying 3 into 2 minus I, then you use the sign plus, which is the sign 2i into 2 minus I. That's to say, you can use these terms to multiply by this. I use the first term against this, use the second term against this. And if you split this, 3 times 2 will be 6. 3 times minus I will be minus 3i. This times this, I think this looks more easier, and this times this will be minus 2i squared. That gives exactly what we're having here. So let's keep moving. We know that I squared is minus 1, so this will be 6. If you add up this, what you have as the answer will be 1, because minus 3i plus 4i will give us just I, right? Not 1 but I, positive I. And then here will be minus 1. So if you put minus 1 here, it means you'll be having 6 plus I plus 2. So finally 2 will add up to 6 to give 8 plus I, and that is the result to this particular problem. And then let's see other problem remaining. I think we just have but 2 extra problems to round up this section. And the first one we're having here is this multiplies through this. So what do? We use the associative law of multiplication. How does that work? So for this IV number 4, we're going to do this. We'll repeat the first one we have in I minus 2, and then use this 2 to distribute this, 3 to distribute. So if we do that, then we'll be having 2 times I, or 2 times 1 rather, is 2, plus 2 times I will be 2i, and minus 3 times I will be minus 3i, and minus there will give plus. 3 times 1 is 3. So you can see how we are able to use the associative law to distribute. So we still have to maintain this I minus 2 first and keep this to balance. And if we do that, 2 plus 3 will simply give us 5, and 2i minus 3i will give minus I. So finally we can be able to expand this, and if you want to expand this, you can just use I over 5 minus I, and then use minus 2 over 5 minus I. So if you expand this, what should we have? I times 5i will give us 5i. I times minus I will give us minus I squared, and minus 2 times 5 will give us minus 10, and minus 2 times I will give us plus 2i. So we know that I squared is minus 1, so this will change to plus 1. So 5i. So we know that this I squared is, if this gives minus 1 times 1 will give plus 1, and here we have minus 10 plus 2i. So let's add up this 1 and this. Of course, 1 minus 10 will give minus 9, and then plus 5i plus 2i will give 7i. So this is the result to this problem. So the last one we have in here is on division. So that question says 2 minus 3i all over 4 minus I. So let's quickly solve this problem. And we've discussed division of complex number. And when we talked about that, we say we're going to multiply by the conjugate of the denominator, which is 4 plus I dividing 4 plus I. That's what we discussed. So now the numerator multiply the denominator and the denominator against denominator. So firstly, on the numerator, we say 2 multiplied by 4 plus I, and then minus 3I multiplies by 4 plus I. That's on the numerator. Denominator, we have 4 multiplies by 4 plus I minus I into 4 plus I. So what's the result of this? 2 times, let's use this part. 2 times 4 gives us 8, and 2 times I will give us 2I. Minus 3I times 4 will give us minus 12I, and minus plus will give minus. 3I times I will give 3I squared. And this divides 4 times 4 is 16, and 4 times I is 4I. Again, minus I times 4 is minus 4I, and then minus affecting this plus will give us minus. I times I is I squared. Minus I, 4I minus 4I, that will be 0. And on the numerator, we'll be having 8. 2I minus this will give minus 10I. Right? 2I minus 12I will give that. And keep in mind that I squared is minus 1. Minus 1 times minus 3 will be plus 3. Right? So we have the denominator to be, this is I squared, which is minus 1, times this one will give 16 plus 1. And then here we have 8 plus 3, that will give 11 minus 10I, all over 16 plus 1 will give us 17. So remember, we said that your answer will always have the form of a complex number. That means in order for that to work, we have just single number on the denominator. So if we use it to divide through each of the number on the numerator, then we have 11 divided by 17 minus 10 divided by 17I. So this is the real part and this is the imaginary part, and this becomes the solution to that problem. I hope you found this video helpful. Consider hitting the subscribe button, turn on the notification button, and when I upload new video you get notified, and like this video. Please share so that people can also get good understanding with the example associated. And then turn on the notification, because the reason is because I want to do more video on complex number to ensure that you have all you need to become dangerous on complex number. Take care. Bye.